Hey, hi, Rajan this side. Welcome to my YouTube channel. Today we will discuss the problem asked in today's LeetCode Biweekly Contest 164. So let's start with the first problem. It says you are given an integer n. You have to find out the digit that occurs least frequently in the decimal representation, right? And if there are multiple having the least frequency, you have to find out the smallest digit, right? For example, in the first test case, the digit having minimum frequency is 1, that occurs only one number of times, so the answer is 1. In this test case, the least frequent digits are 7, 2 and 5. Like all these three digits have the frequency of 1, but like if there are multiple digits having the least frequency, you have to find out the smallest digit. So the smallest digit is 2, right? So yeah, the answer is 2. This is a pretty implementation problem, so I'll directly jump over to the code. This is the code of first problem. So I took a frequency array of size 10 because the possible digits are from 0 to 9. Now what I'm doing, I'm incrementing the frequency of each digit. So this is how we do it. We get the digit by taking modulo and we keep on dividing it by 10. Once you get the digit, just increment its frequency. So once you done the updating the frequency part, now the next job is to find out the least frequent number, right? So this is what I did. I took an answer variable and a frequency variable, initialized it at -1 and int max. Now I'm going through each possible digits from 0 to 9. I just check if the current frequency is positive, means this digit I is at least once present in the given integer n. If it is present and its frequency is less than my current frequency, the optimal frequency, right? If that is true, it means that you get something better. You get a digit that has more lesser number of times it present in the given integer, right? Its frequency is less than my current frequency, so just update your frequency or in your answer, and at the end just return the answer. So yeah, this is the code of first problem. Now let's look at the second problem. In the second problem, you are given a deck of cards, right? And each card displays two lowercase letters. You are also given in the letter X. Now you have to play a game in the following rules. So you have to start with the 0 points, and in each turn, you must find two compatible cards from the deck that both contain a letter X in any of the position. Means X should be present in any of the position. Now you remove both the pair of cards and earn 1 point, and the game ends when there is no longer a way to find the pair of compatible cards, and return the maximum number of points which you can gain with the optimal play, right? And two cards are called compatible if the string differs in exactly one position. All right? Yeah. Let's see how we can approach this problem. So in the second problem, we are given cards and X, right? So what we will do, we will go through each of the cards, and we will try to find a pattern, right? So we will try to find if, let's say, you encountered a card that has two character, right? Let's say this is my first character and this is my second character. I'll try to check if either first case, if both are X, if both the characters are equal to the given character X. The second, if X is matches, then we will store the frequency of the second character. The third case would be if the second character is equals to X. In that situation, we will store the frequency of the first character. Let's say we store the frequency of third type into something called, let's say, a left array, right? And the frequency of second type in something called right array, right array. And we store the frequency of the card that has both the characters equals to X in some variable called both, right? So both will tell you how many number of card that has both the characters equals to X. Now in the problem, if you see, we have to find out the maximum number of compatible pairs, right? And compatible pairs means they differs in exactly one position. See, if you take of type 1 XX and second type X and some other character, right? So they differ in exactly one position, right? And the another possible pairs could be XX and it's something called underscore X. So this is my some different character. They are also differ in exactly one character, right? So both differ exactly what. So this is one of the compatible pairs. This is one of the compatible pairs. But we cannot form a compatible pair of type 2 and type 3 because, so let's say you took a type 1 X something called Z, and third type could be, let's say you took something called A and X. See how many number of different positions we have. This is also different, this is also different, so there are two different positions. So this is not a compatible pair. It means that the compatible pair can be formed only if you have at least one X, like the type 1, at least one of type 1 card you need to form the compatible pair, and for the second it could be either 2 or 3, right? And we have to find out the maximum number of points, right? But we don't know if choosing type 1 with type 2 would give you maximum, or type 3 would be maximum. So what we will do, we will use a loop for int I equals to 0 and I less than or equals to both I plus plus. And now what we will do, we will try to find the compatible pair having I number of card of type 1 with type 2, right, using right array. And so how many number of cards remain of type 1? Both minus I, right? Both minus I. So we will find a compatible pair with both minus I number of card of type 1 with type 3, which is which can be used by the left array. So this is of type 3 and this is of type 2, right? And among all these, so let's say, so there is a function that will give the result, like the number of compatible pairs, and then among all those possibilities from I equals to 0 to I less than both, like less than or equals to both, we will take the maximum one, right? That will be my answer. Now the last job is to find how many number of compatible pairs possible using this concept, like so how many number of compatible pairs possible using I number of type 1 with type 2 plus both minus I number of type 1 with type 3. Let's see how we can calculate the number of compatible pairs having I number of type 1 cards and type 2 cards, right? And once you calculate it, the calculation of this part would be exactly the same, right? So let's say I created a function that would take two parameters. First is this frequency array, like it could be either left and right, and the right one, like the next argument is the count of type 1 cards, right? So now what we have to do, we have to find out the compatible pairs, right? So compatible pairs, so how many cards we have? You have count number of type 1 card and something called, so this frequency, let's say this is f1, f2, f3, so fx. So this is of type 1, and all these are type 2 cards, right? So now how many number of compatible pairs possible? That would be minimum of total. So total is the sum of all these cards. Total cards divided by 2, comma, minimum of this, comma, total minus mx. So mx is the maximum frequency of either like any one of the like either type 1 card or type 2 card. You might like you might think that why there are f1, f2, f3. So let's say there are xa, xb, xc, and let's say xe. So, and let's say few more, xa and xb. See, there are a b c a b c and e. Four are the unique characters present at the second position, right, for type 2. But the frequency are, for a the frequency is 2, right? So this frequency array essentially store 2, 2, 1 and 1, right? Since there are two exactly same cards, right, so we cannot form a pair of so we cannot, for these two cards won't be compatible. XA are not compatible because they differs in no position, both are exactly the same. So we can form a compatible pair with with either type 1 and type 2, or type 2 with type 2, but they are not exactly the same. I mean, they must be different, they must be different type 2, right? So it means that we cannot form a compatible pair with xa and xa. That is why I store the frequency, like each unique frequency, I mean the frequency of each unique cards. So let's say these are f1, f2, fx. The now your total number of compatible pair would be minimum of total by 2 comma total minus x. Let's see how. So we know that like the total essentially the sum of all these cards. We know that your maximum number of cards which can go is only total divided by 2, right? That is the maximum possible cards, because for pair you need 2 cards. So it will be total divided by 2 comma the second part is total minus x. Let's see what it is. So let's say the maximum frequency in either of type 1 and type 2 is mx, right? So let's say this is my mx. So how many cards are left? Total minus mx, right? Total minus mx. So let's say this is majority, this is majority, and this is minority, right? I just call is majority and minority. So in any of the compatible pairs, so we know that the compatible pairs can be formed using either one majority plus one minority, or because we know that we cannot form a compatible pair with both majority, right? Because then it would be same as discussed. We cannot form a compatible pair of two exactly same cards, xa and xa. So means that one would be from majority and one would be from minority. Now the second possibility could be either one is from minority and another one is also from minority, but they are different, right? For example, xb and xa. We cannot, like we can form a compatible pair of these two cards with these two cards. If you notice here, minority is common, right? Minority would be present in all the compatible pairs. And how many number of minority we have? Total minus mx. That is why I use the second part is total minus mx, because these many number of compatible pairs possible, because in any of the compatible pair at least one minority should be present. That is why I use total minus mx. And how many number of minority we have? Total minus mx. So yeah, this is the derivation of how to find out the maximum number of compatible pairs, right? Using I number of, like, so using count number of type 1 cards, and this could be either type 2 or type 3, right? So yeah, let's see how we can write code for it. This is the code of second problem. I would highly recommend to check out the explanation part, because that is the most crucial part in this problem, because this code is exactly same what I have explained in the explanation part, right? So I took left array and right array to store the frequency, and this is my both variable that essentially tells you how many number of type 1 cards present. Type 1 cards means both the characters are exactly equals to x, right? If both are x, increment both plus plus. If the left character is same as x, increment the frequency of right character in the right array. And if the right character is same as x, increment the left character into the left array, right? So after this we get left, right and both. So this is my answer. I'm going through all possible way to divide this both like the type 1 card, because we know that we can uh, form a pair only with one of type 1 and type 2 and one with type 1 and type 3. So this is with I number of type 1 with type 2, and the remaining is both minus I number of type 1 with type 3, right? So this is the calculation function. So as explained in the explanation part, uh, your total is the total sum of all the cards, which is ext, like the count plus all this frequency, and I took the maximum and I returned the minimum of total divided by 2 comma total minus mx. I have already explained why I am like returning the minimum of total divided by 2 comma total minus x. Please check out the explanation part, right? So yeah, this is all about the code of second problem. Now let's look at the third problem. This is the third problem asked in today's contest. So I don't know about others, but I personally feel third problem is much easier than the second problem. Let's see what it says. So it says you are given a binary grid of size m cross n, right? Binary means it could be either 0 and 1. 0 means it's an empty cell, and 1 means there is a mirror on that cell, right? So a robot starts at the top left corner and it want to reach at the bottom right corner. So it can only move to either right or down. Now if the robot attempts to move into the mirror cell, it is reflected before entering to the cell. Let's see what the reflection does. So let's say it moves to the right and there is a mirror, right? So it will kind of turn down. So let's say it is going right, but once it hits the mirror, it will move to down. Okay. Now the second thing, if you are going down and if you hit a mirror, you will move to the right. All right. And if this reflection would cause the robot to move outside of the grid, this path is considered as invalid. Okay. And we have to return the number of unique valid paths to reach from the top left corner to the right corner. And since there could be very large number of possible, you have to return 10 to the power like the answer modulo 10 to the power 9 plus 7. So this problem, I would say, a bit slightly modified version of the original problem. So this is the original problem called unique paths. This is a well famous problem asked in multiple interviews. So in this problem we have to find out the number of ways to reach from the top left cell to the bottom right cell, and you can only move to the down and right? So this problem and this problem is exactly the same, but there is a difference in the mirror. There is a reflection once you hit a mirror, right? So I would highly recommend to solve this problem first, the unique path on the LeetCode itself. So and then we can jump to this problem. So yeah, let's see how we can approach this problem. Solve the third problem. If you had solved the easier version of the problem and you had to find out the number of ways to reach from top left cell to bottom right cell without any mirror and reflection, just a basic top either right and down move, right? So there you would have used a 2D DP array where DP of I j will tell you the number of ways to reach at cell I comma j, right? So let's say this is my cell I comma j. It can either be reached from top or from right? So this is my I comma j minus 1th cell, and this is my I minus 1 comma jth cell. So the number of, so the recurrence relation was dp of ij is equal to dp of I minus 1j, the total number of ways to reach at the top cell, plus dp of I comma j minus 1, the number of ways to reach at the left cell, and the sum of these two. So this was the recurrent relation for the easier problem. But in this problem, in this particular problem, like in today's contest, there is a slightly difference. The difference comes in the mirror. So some of the cells in the matrix may contain a mirror, right? So what this mirror does, it essentially changes your direction. So let's say you are moving to the right, but once you hit a mirror, it will change your direction to down. And the second possibility could be, let's say you are you are coming from the top. You are coming from the top, it will change your direction to right. So this is the what this mirror does, this mirror essentially changes your direction, right? Direction. So, and that is why to handle this direction, like to tackle this direction, I used one extra dimension in the DP array. So now it will look like DP of I is 0. So 0 means the number of ways to reach at cell I comma j, but from the left direction. And DP of ij1 means the number of ways to reach at cell I comma j from the top direction, right? So let's see how the recurrence relation look like. So for this particular case, let's say this is my cell I comma j, right? And this is cell I minus 1 comma j, and the left cell is I comma j minus 1, right? So let's consider the case when your this cell is empty. If this is empty, so if this is empty, then your DP of I, j and 0. So let's say I want to calculate the number of ways to reach from the left direction, right? So there are two possibilities. Either this left cell is either empty or there is a mirror. There is a mirror. So let's consider the first case when it is empty. So DP of ij 0 would be, if this is empty, it means that it just give me the number of ways to reach at this particular cell from any direction. It is DP of I j minus 1. It is either 0 or DP of I j minus 1 1. I don't care how you reach at this cell. If it is empty, means there won't be any reflection. So it could be either this and then this move, or this and this move. Like either way is fine, right? But in the second case, so this is the case when the cell is empty. But the second case, when there is a mirror here, right? So then the recurrence relation would be DP of I j, this is 0, right? This would be DP of I j minus 1. Now it will be 1, because we know that since there is a mirror here, right? There is a mirror. So if you would come from here, if you'd come from left, you would, so this would, like, it will change the direction to down after the reflection. So it won't be this path. It won't go straight. That is why, but if you are coming from the top, right? Let's say there is a mirror. If you are coming from the top, it will be now reflected to here. So only this this case would be considered in the recurrence relation when there is a mirror, right? So I hope you understand this part. And similarly, for the right direction, your DP of I j 1. Let's consider the case when it's empty. It would be DP of I minus 1 j 0 plus DP of I minus 1 j 1. So this is again when it is empty. But if it is a like if there is a mirror here, then your DP of I j 1 is simply DP of I minus 1 j and 0. Why? Because since there is a mirror here, so only those ways would be considered which are coming from the left, because if you are coming from the left and there is a mirror here, it will move to down, right? So to move, to reach at cell I comma j from the top would be the number of ways to reach at I minus 1 comma j from left, because there is a mirror here. So yeah, this is the recurrence relation. Now let's see how we can write code for it. Like if you didn't understand any of the point, please write a comment. I'll reply to all the comments, right? So let's see how we can write code for it. This is the code of third problem. So n is the number of rows, m is the number of column. This is my modulo 10 to the power 9 plus 7, right? This is my DP array. I have taken 3D DP. I have explained in the explanation part why I have taken one extra dimension in the original DP. So the size is 2 means it could be either 0 and 1. So 0 means you are reaching at the cells from the left direction, and 1 means you are reaching to that cell from the top direction. I have initialized it at 0. This is my corner case. So the first case is to build a DP array for the first row. So we know that the number of ways to reach in the first row would be 1, but only if you have not hit a mirror, because once you hit a mirror, it will immediately change the direction to down. So let's say you are keep on going left, right, but once you hit the mirror, it would go to the down. So that is why I just check if there is a mirror here, just break here, because you won't go afterwards once hitting the mirror, because it will immediately move to down. Now similarly for the first column, you keep on going to down, but as soon as you hit a mirror, it will move to the right, so it won't go further. So just break here. So this is the corner case for first row and first column. Now for any general I and j, this is exactly same as the explanation part. To calculate dp of ij 0, just check if your so dp of ij 0 means the number of ways to reach at I comma j from 0 means left direction. So just check if your left cell is either empty or there is a mirror. If it's empty, I don't care how you reach there. So just your answer would be the number of ways to reach at left cell, either from left or from top. But if there is a mirror on the left, I would have to consider only those ways which comes from the top direction, because only top direction would get reflected to right. So it is coming from top, but it will reflect to right. And similarly for the number of ways to reach at I comma j from top, that would be, so if the top cell is empty, I don't care how you reach at the top cell. It could be either from left or from top. But if the top cell, like if there is a mirror on the top cell, I would have to consider only those ways which is kind of going to the top cell from the left direction, right? Because those ways would be like, it is keep on going in the right direction, but once you hit a mirror, it would come to down. That is why I choose the left direction ways only. And at the end, just now the number of ways to reach at the bottom right cell would be either from reach from the left or from the top, and you have to return with modulo mod. So yeah, this is the code of for the third problem. So yeah, if you find the video helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.